Hello everyone. In this video, we are going to understand the problem of traveling salesman using dynamic approach. What we have to do is we have to start from the initial node, and after traveling all the vertices, we have to again reach to the initial node. So over here, I have drawn a graph and the weight of the edges has been displayed in the tabular form. We are going to use this formula to solve our traveling salesman problem, where I is the node at which we are standing and S is the node from where we can go from ith node. So let us start solving it. Now let's suppose I'm starting from my node 1. So I can say that G of I, where I is equals to 1, and state space consists all the nodes that has to be considered. So I can say that I can consider second node, third node, or fourth node. This will be equals to minimum of where your k is belonging to your state space. So this will become as 2, 3 and 4, and the formula that will become as C of ik. So if I'm considering k as 2, this becomes 1, 2 plus g of k is 2, comma, s minus k. S is 2, 3, 4, this is s, and k is 2. So this becomes 3, 4. Similarly, if the k is equals to 3, this becomes C of 1, 3 plus G of k is 3. State space is having 2, 3, 4. We are minusing or we are subtracting 3 from it. So this becomes 2, 4. Similarly, C of 1, 4 plus G of k is 4. State space is 2, 3, 4, and we are going to subtract 4 from it. So this becomes 2 and 3. So this is the first set of equation that we have got. Now we have to solve it for equation 1, 2, and we have to solve equation 3. To solve equation 1, this is g of 2, 3, 4. So this will become equals to minimum of where your k belongs to 3, 4. This will become as C of I is 2, and let's suppose k is 3. So this is 2, 3 plus g of k, s minus k. So k is 3 and state space is 3, 4, where we are taking k as 3. So this becomes 4. And the next equation becomes C of 2, 4 plus G of k is 4, and the leftover value after subtracting k from S is 3. For equation number 2, this becomes G of 3, 2, 4. So this becomes equals to minimum where k belongs to 2, 4. This will become C of I and k, where I is 3 and we are considering k as 2, plus G of k is 2, and if we subtract 2 from state space, then we will be getting 4 over here. The next equation will be C of 3, 4 plus G of k, which is 4, and if we subtract 4 from 2, 4, we will get 2. So this is the next set of equation that we have here. We are having G of 4, 2, 3, which will be equals to minimum of where your k belongs to 2, 3. So this will become C of I. I is 4 over here. S is 2 and 3 over here. First we will be considering k as 2. So this will become ik. This is 4, 2 plus g of 2, we are subtracting 2 from state space. So we will be getting 3 over here. Again, we will be having C of 4, 3 since we have taken k as 3 this time. So this becomes G of k is 3, and if we subtract 3 from S, we will be getting 2. So this is the set of equations that we have get after solving first, second and third equation. Now let us say this equation as 4, this as 5, this as 6, this as 7, this as 8 and this as 9. Let us first solve equation number 4. So this becomes G of 3, 4. This will be equals to minimum of k belongs to, see now there is only one entry, so I am going to say it is equals to 4. So this will become equals to where I is equals to 3 and S is equals to 4. This will be ik, so this is the 3, 4 plus G of k is over here 4, and if we subtract 4 from S, we will be getting 5 over here. Similarly, for equation 5, we will be getting g of 4, 3. This will be equals to minimum of where k belongs to 3. This will be equals to c of 4, 3 as k is equals to 3 and I is equals to 4 plus g of k over here is 3, and if we subtract 3 from our state space, we will be getting as 5. So we would be getting this as 2, 4. So we will be getting this as 2, 4. This will be equals to minimum where k belongs to 4. This will be c 2, 4 plus g of 4, 5. And seventh equation will be g of 4, 2. This will be equals to minimum where your k belongs to your 2. This will be c of 4, 2 plus g of 2, 5. So this becomes g of 2, 3, which is equals to minimum where your k belongs to 3 of c of 2, 3 plus g of 3, 5. Similarly, this becomes minimum of where your k belongs to 2, c of 3, 2 plus g of 2, 5. Now let us solve a problem from the bottom. Now if you can see over here, 2, 5, 3, 5, this means that you have reached your destination, that is your initial node from where you have started. So the node that we have started from was 1. So I can say that 2, 5 means the cost of 2, 1. 3, 5 means the cost of 3, 1. Similarly, the cost of 3, 5 is 3, 1 and 4, 5 is 4, 1 and so on. Now let us fill the values from the bottom. C of 3, 2, we can see that C of 3, 2 is 4. So we are going to put the value as 4 over here. And the value of 2, 1 is 7. So we are going to put the value as 7. So the value of 3, 2 is 11. Similarly, the value of 2, 3 is 6. And the value of 3, 1 is 3. So we can write it as 3. So the value of this becomes 9. Similarly, the value of 4, 2 and 2, 4 are 2 and 2. So I'm going to put 2 over here and 2 over here. The value of 2, 5 we have just seen it is 7 and 4, 5 is 4, 1 which is 3. So this will become as 9 and this will become as 5. The value of C of 4, 3 is 2 and 3, 4 is 3. So 3, 4 was 3 and 4, 3 was 2. The value of 4, 5 is 3 and 3, 5 is again 3. So this becomes as 6 and the value over here becomes 5. Now we are going to put these values in our third, second and first equation. So the value of 2 and 3 that we got was 9 and the value of 3, 2 was 11 that we were getting. Similarly, for 2, 4, we were getting a value as 5 and for 4, 2, we are getting a value as 9. For 3, 4, we are getting a value as 6 and for 4, 3, we are getting a value of 5. Now, let us fill other values. So, the value of 4, 3 is 2. The value of 4, 2 is 2. 3, 4 is 3. 3, 2 is 4. 2, 4 is 2. And 2, 3 is 6. Now, let us add these. So, this becomes 13, 11, 12, 9, 7 and 12. So the minimum of 11 and 13 is 11. So I'm going to write this value as 11. 9 and 12 minimum is 9. 12 and 7 minimum is 7. So I'm going to place these values over here. So this becomes 7. this becomes 9 and this becomes 11. The value of C of 1, 2 is 5, 1, 3 is 3, and 1, 4 is 6. So the total value that I would be getting is 12, 12, and 17. So the minimum value I'm getting is 12. You can get it either from this or you can get either from this. So the solution to the traveling salesman problem, I'm getting a value of 12. I can take any direction. If I take this direction, then I would have taken the path as 1. Then if I see this one, I was getting this minimum value from this. So this becomes 2, 4, and 3. Or else I can take the path from this one. So if I take the path from this one, this becomes 1. I have to check for this one. So for this, I was getting a minimum value from this direction. So this becomes 3, 2, this is 3 and 2, then 4. So if I traverse from the vertex 1, 2, 4, 3 or 1, 3, 2, 4, I will be getting a minimum cost of 12. So this is all about your traveling salesman.